Good morning, everyone. Last class, we have discussed regarding operator precedence in case of data flow architecture, and similarly, we have discussed regarding the conditional operators as well as replication operator and concatenation operator as well as shift operators. So today, let us consider some example. So when we are going to consider the examples, so first we can able to write the multiplexer program, and this we might have already discussed in previous classes, that is how to write program for multiplexer in gate level architecture. Similarly, when we are going to write program using data flow architecture, we can consider this format. So here we are going to consider the keyword assign and then the corresponding output variable out. And then here we are indicating, that is when both S1 and S2 are 0, I naught should be active means I have to negate S1 as well as S naught. If it is a gate level program, I have to use NOT gate as a inverter and then AND gate. So instead of that, here I am performing the corresponding operation. So here you can see NOT is a unary operator. So it will going to negate one bit value present in the input port S1, and similarly it will negate the value present in the input port S0. And here you can observe that I have placed the parenthesis, isn't it? And between this NOT operation are two different NOT operations, we have mentioned an AND operator, but here I have not placed any parenthesis because since NOT is a unary operator, first preference will be given for negation, and after negating then it will going to perform the AND operation. Okay, and yesterday we discussed that the preference. So first preference, when we compare AND as well as OR, the first preference will be for AND and the next preference is for OR operation. So similarly here we can see that for here also we are having OR operation, but why we have to place parenthesis means if we do not place the parenthesis, then what happens? It will going to do this AND operation first and then it will OR the data with I2 and once again it will perform the AND operation. So like this it will going to perform and we are not able to get the correct output. So in order to get the correct output, we have to mention for which operation has to be done first using the parenthesis. So that is why here for every input selection I am using the parenthesis. Okay, and here you can observe that since NOT is a unary, we have not used parenthesis. So first it will going to compute this and similarly it will compute this. Every expression, this is treated as one expression and this is treated as another expression, like this. So every expressions will be computed and then all the results will be ORed. And finally, one bit output we are going to get, that will be assigned to out. Okay, and which particular bit value will be assigned to out, it depends upon the selection lines S1 as well as S0, because in these selection lines if any one of the selection line is 0, then the corresponding AND operation output will be 0. So as a result, if the selection line value is 0 0, in that case these two, that is S1 bar and S0 bar will be 1, and here I have taken the input as 0 means since S0 is 0, for this particular AND operation output is 0, and here since S1 is 0 because I have taken S1 directly, I have not negated. So as a result this output will be 0, and here S1 and S2 are directly taken, we have not negated, so we will be getting the output as 0. And now these two are equal to 1, as a result my output depends upon the bit I0. So like this we are going to consider the statement when we are writing using data flow architecture. We know the operation of multiplexer, but we should know how to write program in different architectures or in different levels of abstraction. Okay. And similarly, one more type of writing program. Yesterday, while taking the example of conditional operator, I have mentioned this. How to write a multiplexer program using a conditional operator. This is one of the example. For the same program, here you can see the module definition and IO port declaration are same. Only the assignment statement has been changed. So in this case, I am using the conditional operator, that is ternary operator I am using. So as a result, first it will going to check the value of this operand. If this value is 0, then it will going to select this part, because value is 0 means it is treated as false condition and value is 1 means it is treated as true condition. So when it comes to this part, then it will going to check one more control, that is nothing but S naught. If S naught is also 0, then it will going to give the data present in I naught to out. Okay. Suppose if S naught is 1, then the value present in I1 will be assigned to out. This is how the conditional operator will going to use. And while writing the data flow architecture for multiplexer, either I can use this type of statement, or by using the logical operators, we can able to consider this type of statements. That is using the unary operator as well as this binary operator. So these operators are bitwise operator. So as a result, it will going to perform bit and operation. Okay. And similarly, this is also a bit operator, because I've used ampersand as well as this and symbol only once. If I'm using twice, then it will be treated as logical operator. But here I'm using those symbol only once, means they will be treated as bit operator. And again here, what happens? It is having more than one input. So as a result, it indicates that it is a binary operator, not a unary operator. Okay. This is how we are going to consider. And next, one more example what we are having for data flow architecture to get the full adder. So we know that a 1-bit full adder will be having 3 input XOR gate as well as AND gates to calculate sum and carry. But here what happens is, when we are going to consider more than 1 bit, so in a single statement we can able to write, because we know how to use arithmetic operator, isn't it? So in ALU program also we have seen, and in this program also we can observe that when we are going to consider this n bit addition, that is nothing but when n may be 1, 2 or any bit. So using only this particular statement, we need not necessary to change the executable statement. We will get the correct output. The only thing is, if there is any change in the input size, I have to mention over here. Even if it is a 4-bit, the same statement will work, and even if it is a 30-bit, the same statement will work. So here what we are doing, we are adding all the 3 inputs, and we know that if A as well as B are 4-bit, after performing a addition, we may get 1-bit carry. Since this is a binary, we are going to consider 1-bit carry. So when a 1-bit carry exists, the size will going to overflow. So when there is a overflow in size of sum, the carry will be stored in Cout. So for example, let me consider A is equal to 1101. Okay. And B is equal to 1111. Okay. So now when we are going to perform the addition, what happens? 1 plus 1 means we will be getting the value 2. So in that, LSB is 0 and MSB is 1. So LSB will be retained here and MSB will be taken as a carry. And now we will going to perform addition with carry. So as a result, again we are going to get the value as 1, 0. So 0, LSB is stored here and MSB is taken as a carry for next bit addition. And similarly here, since there are 3 bits, when we add all 3 bit ones, we will be getting the output as 1 1. So we will keep LSB 1 here, and this one will be the carry. And now what happens? Again we are having 3 bits, so we will be getting LSB 1 and then 1 bit as a carry. So according to that, we have to get this as a output. You can observe in ALU. In ALU program, we have written the statements A plus B, isn't it? So there you may observe that when we are going to perform this type of addition, only this part will be taken shown in the output. Why only this part is shown in the output means I have considered sum is equal to 4 and size of the sum is equal to 4 bit, and even size of A and B are also equal to 4 bit. So as a result, this fifth bit has been discarded if we do not consider the any variable to save the carry. So that is why here what I am doing is I have taken sum as 4 bits only, but whatever the carry is there, that I am concatenating. Okay, so after executing this statement, the value will be equal to 11100. So here what it indicates, this indicates we are having 4 bit sum and then we are having 1 bit carry out. So we need not necessary to write a separate statement for carry and a separate statement for sum. Okay, so directly by using this arithmetic operator and as well as the concatenation operator, we can able to write only one statement. But provided here, since we are considering the arithmetic operator, so the corresponding circuit generated by the device will going to change. Okay, and the same statement will hold good for any number of size, that is A as well as B. And even see, if the sum is equal to 5 bit instead of 4 bit, if the sum is equal to 5 bit, then I need not necessary to perform concatenation. While declaring only, if I declare sum as 4 down to 0 and inputs as 3 down to 0. So what it indicates, inputs are of 4 bits and output is of 5 bit. So in that case, we need not necessary to use cout and we need not necessary to perform concatenation. Since sum can hold 5 bits of data, it can able to store the carry also. Okay, so this is how we can able to consider the program using data flow operator. And these are some of the examples, like how to write program using data flow architecture. Similarly, you can try the program for encoder, decoder, and any other operators, okay, any other combinational circuits, not sequential circuits. So you know the difference between combinational and sequential circuits, isn't it? So whenever we are going to use sequential circuits, we will be using clock signal. When we are having combinational circuits, in that case, there will be no clock signal. So all the statements are executed parallelly. And while using data flow operators, in that case, we have to consider all the statements as concurrent statements, and using these type of expressions, we can able to write program. Okay. And this completes your third module. And next, let us start fourth module. Can you all able to see this fourth module? Can you all able to see this PPT of fourth module? I'm not getting any reply. Okay. So in the fourth module, mainly what we are going to discuss is behavioral modeling. So till now we have considered gate level modeling as well as data flow modeling. So in case of gate level, when we know the circuit, then according to the circuit connection, we are going to write the program. And in case of data flow modeling, we don't know anything about the circuit, but we will know how to get the output using the expressions. So to write the expressions, we are going to consider the corresponding operators like arithmetic, logical, binary, all these operators we are going to consider. and we will obtain the output. And next what we are having is behavioral level. And whenever we are going to consider behavioral level, mainly this is called as sequential modeling, because behavioral modeling, why we are going to use this type of modeling means some part of the circuit depends on clock signal and some part of the circuit are combinational circuit. But using data flow or gate level, we cannot able to generate any sequential circuit. If I want to consider any sequential circuit, then I have to go for behavioral modeling only. So that is why in order to implement sequential circuits, we'll go for behavioral modeling. If there is no sequential circuit in our program means, in that case, you can go for either gate level or data flow modeling. Whichever it is easy, that can be used. But in case of sequential circuits, we have to consider behavioral modeling only. Okay. And also one more thing we have to remember, that one particular module need not necessary to consider only one type of abstraction, that is either only gate level or only data flow or only behavioral. We can combine the different levels of abstraction according to the requirement. Because when we consider any real-time circuits, okay, there only few part may be depending on the clock, so they can be considered as sequential part, and remaining part may be a combinational circuit. So in such case, either if I know the complete combinational circuit, I can go for gate level or I can go for data flow. So like this, to get the complete circuit, sometimes I need to use behavioral as well as other level of abstraction. So as a result, according to the requirement, we can able to combine all the three levels of modeling. Okay. So now let us see what we are going to study in this behavioral modeling. So this behavioral modeling consists of structured procedures. So structured procedures means here they will going to execute one after the another. Okay, here order of the statement is important, and whatever these procedure, usually when we are going to consider procedure, what happens, it may not return a value, but it will going to affect the variable, isn't it? So in the same way, these statements will also work. But when we are going to consider a function, what happens? Function has to return a value, isn't it? Procedure may return or may not return. That is optional. So in the same way, here the initial as well as always statement will going to work. And the name itself indicates initial. Initial means it is just like initializing the values, and similarly always means it is just like always it has to keep on executing the statements. So that is why we are going to have two types of procedures, one to initialize and the another one to execute repeatedly. Okay. And the next one what we are having is procedural assignments. Procedural assignments means inside this initial statement or inside this always statement, how we have to assign the value. So to assign the value, here we are mainly there are two types. One is blocking assignment and the another one is non-blocking assignment. So blocking assignment means until the execution of the current statement completes, it will not start the execution of next statement. So the next statements has to wait until the previous statement has to complete its execution. So till then, the execution of the next statements are blocked. So that is why it is called as blocking assignment. And similarly, non-blocking means here they will not going to wait for the execution of previous statement. They'll execute immediately. Okay, so that type of execution is called as non-blocking. And next what we are having is time control. So why we are going to consider this time control means, as I told, the sequential circuits, they depend on clock. Not, it doesn't mean that always we have to use clock. So sometimes they may depend on some other inputs also. So as a result, here what we are going to do means, whenever there is a input, change in the input, according to that the corresponding execution of the always or initial statement will going to occur. But in that time, what type of change, when the change has to occur, so till what time it has to wait, all these things we are going to mention using delay controls. Okay, so we may consider event based time control. So event based time control means whenever an event occurs. See, for example, whenever an event occurs means, see, at your class schedule, immediately you will going to join, isn't it? So till then you will be in different state, and as soon as the class starts, you will be in another state. So when there is a event named class, then the state how you are going to behave will going to change. So that is why when that change will occur, the change occurs because of an event. If there is no event, then there will be no change in the state. If any event occurs, then the corresponding change has been occurred. So like this we are going to consider event based. And sometimes event may not occur, but after some delay we need to execute. So that is known as time control, that is delay based time control. And next one what we are having is level sensitivity. So this, for this I can give an example of latch, isn't it? So there is a difference between latch and flip flop. So what happens in case of latch? So let me consider a D latch. So when I'm going to consider D latch, so here what happens, whenever the value in the D input changes, so immediately there will be change in the output Q. Okay. If it is a level sensitive means what I am going to mention, if the enable pin is high, then whatever may be the input, the same should be given as a output. Okay. And if the enable pin is 0, then whatever may be the value at input, output will not going to change. Means it is sensitive for the level of enable pin. Okay. That type of sensitivity is known as level sensitivity. And similarly, when we understand all these things, then how to use those things to write the program. So while writing the program, sometimes we may use conditions, and sometimes we may use different branches depending upon different initial values or different state of a particular variable. Okay, so in such case, we'll go for if statement as well as case statement. And next, one more type, what we are having is case X and case Z. So when we are going to have input as either X or Z, so in that case, which statements has to be executed? So for that we are having case X and case Z. If I consider only case statement, then what happens? It will going to take only the values of a particular variable with zeros and ones, combination of 0 and 1s. But whenever there is a combination of 0, X or Z and 1, in that case, it will not going to execute, it will go for default statement. Okay, so default statement means in case statement, mainly we are going to mention, it will going to check whether a particular case has occurred. If none of the mentioned cases occur, then by default it has to execute some, it has to give some solution, otherwise we cannot complete the circuit. So that case will be executed. But here in case of case X and case Z, it will treat the inputs of X, input bits of X as well as Y, and using that also we can able to implement the circuit. For example, let me consider like priority encoder. So you know about the encoder, isn't it? So what encoder will going to do? Encoder depending upon the input value, we will be getting the corresponding output. But when I am going to consider priority encoder, first I need to give priority for one of the bit. If that particular bit is given the highest priority, then based on that we will going to get the output. Suppose if that particular bit is not high, then it will give priority for the next bits. So like this, we are going to consider the priority encoder. So in such case, we are going to consider the value, the statements K6 and KZ that we will discuss later in this class. Okay. And next what we are having is loop. So whenever we are considering loop, because some part of the statements should be executed repeatedly and some part of the statement should execute repeatedly for certain period, and some part of the statement should execute repeatedly when a particular condition matches. So here what while loop will going to do means it will check for the condition. If the condition is true, then the statements inside the while loop will be executed. It will going to execute as long as the condition is true. When the condition becomes false, it will come out of the loop. And when I consider for loop, so here what it will do, again here we will be having a loop variable. If I mention it has to execute for 30 number of times with a particular loop variable, then it will going to execute those many times and it will come out. It will not going to check whether the condition is true or false. Nothing it will going to check. It will just check whether the loop variable has reached the maximum or not. Okay. And next what we are having is repeat loop. So here the main difference between for loop and repeat loop is, see, in case of for loop, we are going to use loop variable, and that loop variable can be used in the statements inside the for loop. Okay. But when I consider repeat loop, so in repeat also I'll mention the count. If I want to execute a particular statement 10 times, then I'm going to mention in that repeat loop the number of counts. So that many times it will execute, but there will be no loop variable. As there is no loop variable, inside the statement also we are not using any loop variable. The same task will be done as many times as I mentioned the count. So like this it happens. And next what we are having is forever loop. So this is an infinite loop. See, for example, when we are going to consider clock signal, isn't it? So when the clock at 0th time, the clock will initialize, but it will repeatedly changing its state until you turn off the circuit, isn't it? So that type of looping is taken as forever loop. It will not going to stop until you turn off the circuit. So these type of loops we are going to consider in behavioral architecture. And after that, what we are having is sequential block and parallel block. So this regarding this sequential block and parallel block, here sometimes okay, this example right now I cannot explain in detail, because without understanding the previous topics we cannot able to understand clearly the sequential blocks. So that I am going to discuss when we consider that part of the chapter. Okay. So now these are the things we are going to study in this unit, behavioral modeling. And first let us initialize this. So first let us consider the structured procedure. Mainly there are two structured procedures. One is always and the another one is initial. So when we are going to consider the always or initial statements, so there the statements inside these statements are sequential, but always as well as initial statement are parallel. So that with an example I am going to explain in later slide. So here what we have to understand is mainly there are two types of structured procedures, because within these procedures only we have to write all the behavioral statement. if we write any statement outside this always and initial block, then they are not considered as behavioral statements. They will be treated as a data flow or gate level. So that is why while writing the behavioral statements, all the statements must be within always as well as the initial. Okay. And these statements are considered as active statements. So why they are considered as active statements means they will be completely active until you turn off the device. When once it initializes, then it will be continuously evaluating until you turn off the circuit or device. So that is why they are treated as active elements. And also they will going to execute parallelly. That is what I told. Even though the statements inside this block are sequential, but these statements are parallel. And one more thing, both will start executing at a simulation time 0. So at a simulation time 0 means, see, better let me show this example. So here what happens is, we are having a module stimulus. So in this module, how many statements I'm using? This is one initial statement, second, third initial statements. Okay. But all the three statements start executing from time 0 only. They are parallel, means execution of this statement does not depend on execution of this, or execution of this statement does not depend on this. So all the three will be executed parallelly. So that is why we are going to call that the activity starts at a simulation time 0. Okay. And they cannot be nested, means like how module nesting is illegal, in the same way always block cannot be present inside the initial block, and even initial block cannot be present inside the always block. So that is why it is called statement nesting is not allowed. Okay. And when I consider this initial statement, mainly it is used to initialize the value. So for example, when I'm considering any particular program, let me consider, if I'm considering the outputs of a full adder. So first, initially I will assign the value for sum and carry as 0, because even though until I give the input A, B and C in, the output will be in unknown state. So instead of getting it as unknown state, I will going to initialize. Or else, for example, if I want to generate the clock, so when I want to generate the clock means first I should initialize to 0 and then I can able to negate. Either I can initialize to 0 or I can initialize to 1. But I cannot initialize to unknown or Z. So that is why when we do not give any initial value, in that case, the value will be high impedance. So for that, we may not get the proper output. To observe the output, we are going to use initial statements. Mainly, it is used in stimulus program, because in the stimulus program, we will be giving inputs for the design module, and then we will be checking the working of the design, isn't it? So for that case, we are going to use initial statement. And also one more thing, this initial statement will be executed only once. It will not going to execute repeatedly, because initialization will be done only once. Later, the value can change, isn't it? So that is why initial statement will going to execute only once. So while considering the initial statement, we have to consider or write those statements which has to execute only once, not the repeatedly executable statements should not be written in initial. So that is why inside the initial block, when we are writing the statement, we should be very careful that we have to write only such statements which execute only once in the entire program. So that is what it means. And next what we are having is, if there are multiple initial blocks, then all will going to execute concurrently at time 0. As I told in this example, I am having 3 different initial statements, but all the 3 will start executing at time 0. So that is what it indicates. They are all concurrent statement. Okay. And next, here the execution of first initial statement will not affect the execution of other initial statements. So that is why the block finishes execution independently of the other block, means there is no dependency. Since there is no dependency, all will going to all are considered as concurrent statements. And as I told that when more than one statements are there, we have to use the keyword begin and end. If you are not using the keyword begin and end, then it will take only one behavioral statement under the always or initial block. So that is why in the stimulus program, while writing in the lab, you might have noticed that after initial, I am going to write begin. So why we are going to write begin means there are more number of times we are changing the value of input. So as a result, there will be more executable statements. So that is why we have to use begin and end. It is just like a floor bracket in your C programming. So what we are going to do inside this floor bracket, whatever the statements are there, that belongs to a particular block, isn't it? So this indicates begin and end of a particular block. Similarly, in the Verilog, instead of these brackets, we are going to use the keyword begin and end. It is same for both initial and always statement. Okay. And now let us consider this example. So in this example, here, since there are 3 initial statements, we can observe that in the first initial statement, we are having only one statement, that is m is equal to 0. And I have not mentioned any delay, isn't it? So let me assume that this is the corresponding time scale 0. Okay. And now at 0, m will be assigned with a value 0. Okay. And now when the value of a will be assigned to 1, so even though this statement start executing at the time 0, it has to take a delay of 5 time units. So after this 5 time units, then the value of a will change from unknown to logic high. So initially the value will be high impedance. It is not unknown, since this is a input, so it will be a high impedance. Okay. So the value of a will be changing to the corresponding assigned value 1 at the time 5 units. When the value of b will going to change, whether it will change from the first value or it will going to change at 25 time units. So here, if this is the scale for 10 time units and this is at 15, then 20, and then 25, and then we are having 30, and then 35, finally 40. So like this we are having, okay, time scale. So value of a will going to change at time 5 time units. And now here the value of b. So when it has to change means, see in this case, so here the value of b has to change at time 30 units, because see after executing a, then the statement b has to execute. Okay. So to execute a, first only it has taken 5 time units of delay, and from this it has to take another 25. So 5 plus 25 means, so till the value, that is the time unit 30. Okay, so it will not going to change. It will be in the value z, and when it becomes 30, then it will change to 0. Okay, this is how it will going to consider. See, this is one of the example of blocking assignment. Until the execution of this statement, the second statement will not going to execute. And now when once this statement completes its execution, now it will consider this delay and then it will going to execute. Okay, and similarly we are having the third statement. So here this is also executing parallelly. So what happens when the value of x will going to change? It will going to change at time 10 units. Okay, because even though it has started parallelly, it is having a delay of 10. So it will going to wait for 10 units and then it will going to change from unknown state, high impedance state to logic 0. Similarly, when the value of y will going to change, after executing this, it will take 25 time units of delay and then it will change. Means it will going to change its value at 35, because this is 5 and this is 15 and this is 25. Okay, and this is 35. Okay, so at 35 time units, it will going to change the value. And for inside this initial loop, these two are blocking statements. So until the execution of this will not going to execute. This statement has blocked the execution of the second statement. So this is how we are going to consider, even though they are parallel. Okay, what happens if I write all the statements in only one initial statement? So how we are going to get the output when I am going to write all these statements in only one initial block? So in that case, what it will do? First, it will going to assign value for m, and then it will take 5 time units of delay, and then it will going to assign value for a, and after that it will take 25 units of delay, and then it will going to execute b. After that it will take 10 units of delay and then execute x, and after that take 25 units of delay and execute y. So all the delays will be added. So as a result, finally, as m executes at 0 and a executes after that, means 5 plus 0 is 5. And then b will going to execute after executing a. So we will be going to get the output at 10. And x will going to execute after the execution of b. So we will be going to get the output at 40 time units, and y will going to execute after the execution of x. So in that case, it will going to take time units of 65. So as a result, the last statement will be having a maximum delay, because all these statements have blocked the execution of this statement. So that is why here, if I write all these statements in the same initial block, it will take this much delay. If I write in the separate block, what happens? From the starting, it will take the delay. That is the difference while writing more than one initial statement or a single initial statement. Depending on the requirement, either I can consider more than one initial statement or single initial statement. And this is how, in the same example, this is the fourth initial statement what we are having, that is after 50 time units I'll complete the execution. And here I have given the time at when it has been executed. Since they are parallel, this belongs to one initial statement, and this belongs to another, and this belongs to third one. So this is how we are going to consider the corresponding initial statement. Okay, so in the next class, let us consider the other statements. And now